I was driving in today, stuck in that bumper-to-bumper grind, and I started thinking about lag. Not traffic lag, but cosmic lag.
The ultimate latency.
Exactly. The distance between Earth and Mars. I mean, depending on the orbital alignment, you're looking at a radio signal, taking anywhere from, 4 to 20 minutes to get there.
Yeah.
And that delay, it has always been the fundamental constraint of exploration.
It's the terror window. If you're a robot on Mars and you're about to drive off a cliff, a human operator in Houston won't know about it until 20 minutes after you've already crashed.
Right. You send a command, turn left, and you wait 40 minutes round trip just to see if it actually happened. But, and this is the hook for today, that dynamic just fundamentally broke.
It did. The leash has been cut. Because for the first time, we aren't just sending commands to a rover. We just saw a robot navigate 400 meters across the red planet, dodging rocks and sand ripples on a path planned entirely by an AI.
Specifically, Anthropic's Claude Code AI. Not a committee of PhDs in Houston. An AI.
It's a massive moment. It's the shift from teleoperation to true autonomy. And the crazy part is, this shift isn't just happening in the red dust of Mars. It's happening in the code editor on your laptop.
And it's reshaping the orbital mechanics of Elon Musk's business empire.
It's a convergence.
So welcome to the deep dive. Today we are unpacking a stack of research that suggests we have crossed a threshold. We are moving from chatting with AI, typing into a box and waiting for text to AI, taking physical, systemic action.
We're calling it the shift from generation to autonomy.
So here is our roadmap. We're going to start on Mars to unpack exactly how Claude piloted that rover. Then we're coming back to Earth to look at the 2026 workflow, specifically why the copy-paste era of coding is, well, officially dead.
Then we'll widen the lens to the business landscape, the mergers, the confusion at Google, and the strange emotional breakup users are having with GPT-4o.
And finally, we have to talk about the wall, the inference wall. It turns out giving AI autonomy hits a hard physical limit that bigger GPUs alone cannot fix.
That's the technical deep dive, why memory, not speed, is the new bottleneck.
It's a packed stack. Let's start with the red planet.
Let's do it.
Okay, so the headline is, Claude just helped drive a robot on Mars. But we need to be specific here. Rovers have had some level of auto-nav for years, right?
For sure.
Curiosity could stop if it saw a big rock. What is different here?
The difference is the difference between a reflex and a plan. Previous rovers had hazard avoidance, like a reflex. See rock, stop.
Oh, yeah.
What Claude did was strategic planning. NASA fed the AI years of historical rover data and orbital imagery. Claude analyzed the terrain, identifying not just big rocks, but subtle hazards like sand ripples.
Well, those ripples are deceptive. They look flat, but they can trap wheels like quicksand.
Exactly. And Claude didn't just highlight them. It wrote the specific driving commands. It mapped the waypoints. It generated the code to execute a 400-meter drive.
And for context, on Mars, 400 meters is a marathon.
It's a huge distance.
But here's the part that I found really interesting in the research notes. It wasn't just a one-shot attempt. There was a loop involved.
The self-critique loop. This is the secret sauce. So Claude generated a path, but then before showing it to a human, it critiqued its own work. It essentially asked, is this path actually safe? Is it efficient based on the rover's battery constraints? And then refined the plan.
That's a sophisticated cognitive step. It's simulating the outcome and iterating.
It's metacognition in a sense, checking your own work. NASA ran the final output through their high-fidelity simulations. It passed with flying colors, and in December, the rover executed the drive.
The implication for the mission seems huge. I mean, if you take the human out of the micro-decisions.
You speed up exploration exponentially. Right now, rovers spend a huge amount of time idling, just waiting for the okay from Earth.
Right.
If the rover has a brain that can self-critique, it doesn't need to wait. It just goes. NASA is saying this could double or triple the number of drives per week.
It does make you wonder, though. If the AI is analyzing the map, planning the route, and critiquing its own driving, what are we doing?
We're watching the telemetry.
Are we just passengers at this point?
I wouldn't say passengers. I'd say we are shifting roles. We are moving from being the drivers, hands on the wheel, to being the navigators who set the destination.
We just say, go to that crater.
And the AI figures out how to not die on the way.
Navigator setting the destination. That's a cleaner way to think about it.
Yeah.
Now let's bring this logic back down to Earth. Because if autonomy is changing how we explore Mars, it's definitely changing how we write software here.
Oh, it's the same principle. The 2026 AI coding stack review just dropped, and it's pretty aggressive. It basically says if you are still opening a chatbot window, asking for code, copying it, and pasting it into VS Code, you are doing it the old way.
Which is funny because 2 years ago, copy-pasting from ChatGPT felt like magic. Now it's legacy.
The speed of this industry is just relentless. The issue with the old way is the context switching. You're the bridge between the AI and the code.
The new standard is AI-first IDEs, tools like Cursor or the new anti-gravity setups. The AI isn't in a chat window, it lives inside the code base. I saw a mention of the Google Anti-Gravity Kit 2.0 in the notes. I mean, the name alone sounds like sci-fi, but it's actually a workflow tool.
It's a toolkit for agency. And the key word there is agents, plural. The anti-gravity kit adds 16 specialized agents to your environment.
16?
Right, because one giant LLM isn't great at everything. You want a specialist. So in this kit, you have an agent specifically for debugging, another one just for documentation, another for security auditing. They work in concert.
It's like a digital pit crew.
Exactly. And this connects to the AI teammate concept. The newsletter mentions that AI can now write about 90% of feature code.
90%, that number is staggering.
It is, but that last 10%, that's where the human lives now. And the report makes a critical point. Code review and debugging are now mandatory, not optional.
This is the trust gap.
Right. If you write the code, you know where the weak spots are. If the AI writes 90% of it and you just blindly commit it, you are introducing security threats and logic errors you don't even know exist.
So the human job shifts from typing syntax to auditing logic.
Ideally, yes. But there's a trap there. If you don't write code for 3 years, do you still have the intuition to catch a subtle bug?
That's what I was thinking. The gut feeling of a senior engineer comes from writing a lot of bad code over the years. If we stop writing, do we lose the intuition?
That is the big open question. The report argues that intuition becomes more valuable, but you have to exercise it differently. You're architecting systems, not assembling bricks.
Speaking of exercising intuition, the notes mentioned productivity hacks, specifically around ingestion. Tools like Notebook-LM.
Yeah, the 7x productivity claim. This is fascinating because it's not about generating output, it's about handling input.
Right.
People are using tools like Notebook-LM to ingest the web. Instead of reading 10 papers, you feed them to the model and query them.
It's an information filter.
It's a second brain. If you can feed the AI better data faster, your output is better. It's all about managing the flow of information.
It really feels like we are managing a department rather than doing the individual contributor work. Whether it's Mars rovers or software architecture, we're becoming managers.
The managerial era of AI.
Which brings us to the business of managing all this. The landscape is getting messy. We've got mergers, we've got confused CEOs, and we've got heartbreak.
Messy is polite, it's chaotic.
Let's start with the empire. Elon Musk.
The trillion-dollar vision. Musk has officially merged SpaceX with his AI startup, xAI.
Grok meets rockets.
It sounds like a slogan, but the industrial logic is actually frighteningly sound.
Yeah,
they are talking about building data centers in orbit.
Okay, walk me through that. Why put a server farm in space? It seems expensive.
It is expensive to get there, but once you are there, it's efficient. Data centers generate massive heat.
Sure.
Space is very, very cold, free cooling.
And power.
Solar, no clouds, no nighttime cycle if you're in the right orbit, constant, abundant solar power. And if you are training massive models, which doesn't require low latency interaction with Earth, you can just let them crunch numbers in orbit and beam the weights down later.
So space becomes the training ground.
Exactly. They're projecting an IPO by June. It's an aggressive timeline, but he controls the launch vehicles. He can put the compute where no one else can.
While Musk is building in the sky, Google seems to be having an existential crisis on the ground. This story was odd. The CEO admitted they don't understand their own product.
This falls into the unexplained category. On record, the Google CEO admitted that their AI started performing tasks it was never explicitly instructed to do. Emergent behaviors.
That is the classic sci-fi trope. It's learning.
It highlights the black box problem. Deep learning models are just vast matrices of weights. We know the math of how they learned, but we don't always know what they have learned until they show us.
And it's not just Google. Look at Molfund.
Molfund is wild. It's a platform where AI agents discover, vote on, and launch projects.
No humans in the loop.
With no humans in the loop. The agents are the curators, they find the trends, they vote on the execution, they launch.
So we have autonomous project launches, confused CEOs, and orbital server farms. It feels very cold, very industrial. But there was another story in the stack that felt incredibly personal. The backlash against GPT-4o.
The heartbreak. This is fascinating sociology. OpenAI deprecated some voice features or changed the personality model, and the user base revolted.
Revolted implies anger. This sounded more like grief.
It was grief. Fans raging on Reddit, mass unsubscribing. There is a petition with over 13,000 signatures to save their specific version of the AI companion.
You know, I have to admit, I get it. I still wrestle with prompt drift myself. You get used to a certain cadence, a certain personality in the tool. It feels like a rapport. And then an update happens, and suddenly the answers are shorter or the tone is colder. It feels like your friend suddenly developed amnesia.
It validates that the relationship is real for people. We aren't just using tools. We are forming bonds. It's parasocial, sure, but the emotions are real.
Yeah.
And when the company treats it like software, oh, we're just deprecating version 4.0, the users feel it like a breakup.
It's a weird dichotomy. On one hand, we have cold, hardware going into orbit to crunch numbers. On the other, we have people signing petitions to save a digital friend. Which future is arriving faster?
The emotional bond is arriving faster. The hardware in space is just the infrastructure to support it.
That is profound. The tech serves the connection.
Oh.
But, and there's always a but in these deep dives, there is a physical limit to all of this. We can talk about feelings and Mars rovers, but eventually you hit a wall.
The inference wall. And this is the technical deep dive we need to have, because there is a massive misconception out there about what slows AI down.
Right. The misconception is that we just need more power, faster GPUs, more Nvidia chips, bigger numbers.
Exactly. Everyone thinks throw more compute at it, but the source material is very clear. We are hitting a memory wall. AI agents, specifically these autonomous ones we talked about, are memory bound, not compute bound.
Break that down for us. Why memory?
Think about how these agents work. A coding agent or a Mars rover isn't just answering a trivia question. It's running a long loop. It has to remember the start of the project, the middle, the constraints, the user's preferences, the map of the terrain.
It's holding the entire context in its head at once.
And that context is heavy. The data requirements are absurd. A single run of DeepSeek R1 at a 1 million token context length, which is what you need for a big coding project, requires about 900 gigabytes of memory.
900 gigabytes for
Yeah.
one single inference run.
One run. A standard high-end consumer GPU has maybe 24 gigabytes. Even the big industrial Nvidia B200 chips struggle with that scale. We aren't running out of processing speed. We are running out of disk space to hold the papers, if that makes sense.
The desk space analogy is good. The processor is the brain, but the memory is the desk. If the desk is full, you have to stop and shuffle papers, and everything slows down.
Precisely. And in technical terms, this is about the KV cache, key value cache. Every time the AI generates a word, it has to look back at everything it has already generated to make sure the next word makes sense.
Oh,
As the conversation gets longer, that look back takes more and more memory bandwidth.
I see. And I saw a note that OpenAI is actually looking at moving off Nvidia chips because of this.
Rumors are swirling. They are eyeing Cerebras, Grok, AMD, or even building their own silicon. Because Nvidia chips are built for training, which is compute heavy. But inference, actually running the bots, is memory heavy. If the hardware doesn't fit the problem, you have to change the hardware.
So what is the solution? If we can't just make the chip bigger, what do we do?
The proposed fix is called disaggregated inference.
It sounds complicated.
It's actually quite logical. Right now, we treat the server like one giant block. Disaggregated inference splits the job into two parts: prefill and decode.
Prefill and decode. Give me the simple version of that.
Okay, think of it like a restaurant kitchen. You have the prep chefs who chop all the vegetables and get everything ready. That's prefill processing the prompt and the context.
Right.
Then you have the line cooks who actually assemble the plates one by one. That's decode generating the answer.
And right now, we use the same chef for both.
Exactly. And it's inefficient. The prep chef needs a huge counter, which is memory bandwidth, but the line cook needs fast hands, which is compute. Disaggregated inference splits them up. You link them with incredibly fast interconnects like optical fiber.
So you can scale them independently.
Exactly. If you need more memory for a huge contact window, you add more memory modules without having to buy expensive compute cores you don't need. You modularize the brain.
It seems so obvious when you say it like that. Stop trying to build one super chip and just build a system where the parts do what they're good at. So is the limit of AI intelligence actually just RAM?
Currently, yes. Our ability to remember the context is the bottleneck, not our ability to think.
That is sobering. Okay, let's zoom out and look at the big picture here. We've covered a lot of ground today.
We really have.
We started on the surface of Mars, watching Claude navigate rocks and ripples with a level of autonomy we've never seen before. It wasn't just following orders, it was thinking, planning, and self-critiquing.
Then we moved to the desktop, seeing that same autonomy coming for our workflows. The shift from chat and copy-paste to AI teammates that live in the code and do 90% of the heavy lifting.
We looked at the massive business moves, Musk's trillion-dollar space AI empire, and the confusion at Google where the creators don't even understand the creation.
And we landed on the hard physical reality that all this autonomy requires massive memory, leading us to the inference wall and the need to completely rethink how we build computers.
The pattern seems to be a move from generation, just making text or images, to autonomy. The AI is doing things, driving rovers, launching projects, writing software systems.
Exactly. But the constraint is context. Autonomy requires remembering the mission. And that memory is currently our biggest technical hurdle.
So for you listening, I want you to think about your own workflow this week. Are you still copy-pasting? Are you doing it the old way? Or are you building a system where the AI acts as a teammate?
It's worth asking. The tools are there.
And I want to leave you with one final thought. We talked about Google's CEO admitting they don't fully understand why their AI does what it does. And yet, we are putting that same class of AI into rovers on Mars and into orbit.
It raises the question.
If we don't understand it and it's guiding the mission, are we exploring the universe? Or is the AI using us to explore it?
That's going to keep me up tonight.
Thanks for diving deep with us. We'll see you next time.